All right. One more thing that I have to include in the limit points. Those who have not watched the video of the limit point theorem related to limit point can watch the previous video. Also, one more thing that I want to add up that I have already said previously, that a finite set has no limit point because its finite set does not contain infinitely many points of E. That contradicts the fact that E is a finite set. So hence we can say that finite set does not contain a limit points. Hence, finite set. Well, from this we can conclude that finite set is closed since it does not contain a point other than E. Alright. Now in this video I'm going to highlight some concept of closed, open and perfect bounded sets. For that I have to for example, a finite set that we have already seen, it is closed because it does not have the option or the chance for getting the points of other sets. It does not have the probability of I don't get the proper word for that, but the finite set does not have a limit point that we have already seen, so it will not have other points other than the point of itself. So from that we can say that the finite set is a limit point. For example, we have a finite set that is integers. The set integer is closed. The set of integers is closed because there is no limit point consists. And if there is a limit point exists, then it belongs to Q, not E, not Z. So we can say that set of integers is a closed set. Now we can also say that set of all complex numbers will also act as a closed set as well as open set, because every limit point of E, if you're considering that complex numbers set equal to E, for example set E, we are considering the complex number set E, we say that this complex number closed or open accordingly. Close because every limit point of E is a point of E, right? So that means we can say that it contains a limit point and it is infinite, so it is also open, and also every point of E is a limit point of E. So there is one more definition for a closed set. All right, and then we have perfect concept, the perfect set. When we consider a perfect set, if every limit point of E is a point of E and every point of E is a limit point of E, so we consider that at the time that these complex numbers is a perfect set. All right. Now, for example, the set of all integers is not a perfect set because the limit points of this set of integers does not belong to set of all integers. So we can say that it is not a perfect set. Set of all integers is also not open. All right. So this is pretty much simple concepts that I have to highlight. All right. So in the next video, sorry, not in the next video, the next concept that we have here is we are dealing with all right. The concept, this theorem is particularly based on De Morgan's law. Those who have not known that what is De Morgan's law, is pretty much says that if you're having a union of E, if you have added complement, it says that it will be equal to intersection of E complement. That's it. All right. This is pretty much, it says that if union is there, if we are adding complement, it will become intersection. If E is there, if we are adding E complement, it will become E complement. For example, if E is open, then we can say that E complement is closed. All right. The next theorem that we are having here is the next theorem that we are having is let E alpha be finite or infinite collection of sets, then basically we are saying that union of E alphas complement will be equal to E alpha complement, right? We are naming it A equal to this and B equal to this. All right. Sorry for that. All right. If, for example, if X belongs to A, all right, means X belongs to this complement, E alpha complement. That implies X does not belong to E alpha. All right. For example, now if I can consider X belongs to intersection of E alpha complement, if X belongs to the intersection of E alpha complement, then we can say that since this part right over here equal to B, we can say that X belongs to B and X is a subset of A is a subset of B. All right. From this, now if X does not belong to E alpha, we can say that X does not belong to union of E alphas. That is, X belongs to union of E alpha whole complement. So from this we get B is a subset of A. Right. If we are assuming that X belongs to B. Alright. So from this we can get equal to B. Right. This is easy. Alright. The next theorem. Alright. Next theorem is that if a set E is open if and only if its complement is closed. We have closed sets, we have open sets. We know the definition of closed sets. Alright. Whenever we consider closed set when limit point exists, and open set when every point of E is an interior point of E. That's it. So we are considering E. Alright. And this one is E complement. Alright. This whole thing is belongs to x-axis, X3 metric space. Now we have to prove that there is a point X belongs to E. Alright. And it is a limit point of E since it contains points other than X in the neighborhood of X. Hence we can conclude that X is a limit point of E. From there it implies that E complement is closed, and since X belongs to E complement, X belongs to E complement, we get that X does not belong to E. Right. So conversely, if suppose E complement is closed, conversely we know that E complement is, we are proving that E is an interior point of, there is a point in E, X belongs to E. For example, conversely, we are assuming that E is an interior point of E, then X does not belong to E complement, and X is not an limit point of E, and also X resides completely inside inside E, we get that X is an interior point of E. All right, and from this we can conclude that E is an open set and E complement is closed set. All right. If you take the for precisely, if you consider a neighborhood of X that is denoted with N, so N intersection E complement, you will get phi. Basically, this is what the interior point definition means. Interior point definition is. So from this we get that E is open if and only if its complement is closed. All right. For systematic steps, you can follow your textbook or from wherever you're trying to study from. All right. Next theorem that we are considering here is, all right, so next theorem that we have here is that G alpha are the collection of open sets. Then we have to prove that union of G alphas is open. All right, we just have to prove that. First thing that you have to consider that whenever it came open set is given, you have to think that that implies that it consists of an interior point, and every interior point of E, for example, G interior will be equal to G alpha J for some J. So every G interior of J alpha J is equal to G alpha J. All right. So this thing that you have to keep that in mind. So you just have to prove that take a point X and belong that create a neighbor of the X that is N is NBD of X. All right. Then each and every X of G, since N is a subset of some G alpha, right? All right. So we get that imply that N is a subset of G, and it is not just a subset. It is a proper subset of a G, proper set of a G. So we can say that every point of N is an interior point of G. From this we get that G is open. All right. So this is pretty much about the one more theorem. And another theorem that we have here is that if G1, G2, so on Gn is finite collection, all right, finite collection, then we have intersection of Gi's where I goes from 1 to N. 1 to N is open. Basically, you have to just take out the intersection, prove that this is open. If G and G alpha are open sets is given, then this is open sets. All right. You have to prove that. All right. We just have to prove that intersection of Gi is open, right? For that, what you have to prove that every point of neighbor every point of Gi belongs to this Gi, and it is an interior point of these Gi's. Hence, we can prove that Gi is open set. For that, we have to consider a neighborhood of X. That is NBD, which belongs to that intersection of G alpha i's. All right. With the minimum radius. For each and every i's, that is each and every alpha I, that is 1, R1, R2, R3, so on, Rn, right? Which are all these r's are greater than 0. All right, all these r's are greater than 0, and then we are considering that there is a neighborhood NRX, the lowest of all the neighborhoods. There is the radius in the neighborhood which we are constructing is the lowest of all these r's which belonging to G alpha i's, and then we are making this is as a subset of NIX. NIX means all the neighborhoods of X with I indexes, and then we know that this all is a subset of gi's. Now from this we can get the this nrxi with the minimum nrx with the minimum r of all the neighbors of this gi will contain in all the gi's. You can write g1 g2 sorry intersection so on gn. All right, so this is pretty much you have proved that nrx is a interior point of this gi's intersection of gi's, and from that we get that this every point every neighbor of x belong to intersection of gi. From there we get that intersection of gi is an open set. For systematic procedural writing, you can follow your textbook. All right, now we have one more thing that we can use to explain this concept by using the De Morgan's law. That is, consider that H is equal to intersection of gi's. All right, we have to prove that this is closed. All right, intersection of gi's is closed. So for that we have to consider that we know that H complement will be open, right? Will be open. For that we have adding complement on both sides. We'll get intersection gi whole complement. We get union of f alpha complement. We get the f alpha complement is open. All right. Similarly, you can do for this as well. F is equal to union of sorry for that. This is F. Whatever you want to take it. This is just general open sets. F alpha, Fi. We have Fi's, union of Fi's. So if this Fi, if this is closed, then we can get Fi complement is open, right? How do you get complement? Adding complement on both sides. Open. F complement, we get intersection of Fi complement. We get that it is open. This is pretty much easy. All right. Now we can prove that Cartesian product of two open intervals is also open. If I consider two open sets, for example a comma b cross c comma d, open sets. This a is another a is open set, b is also open set, c is also open set, and d is also open set. Two open set, two open intervals. Two Cartesian product these two open intervals is also open. We have to get this. The explanation is pretty much easy. Like for example, there is a point x belongs to a comma b cross c comma d. Then we get that x is equal to x1 comma y1, where x1 belongs to a comma b, y1 belongs to c comma d. All right, we've got the epsilon neighborhood for that. Since x1 belongs to a comma b, implies it's an interior point. Since it's an open interval, all right. Now for that we have neighborhood for x1, that is epsilon 1 is a subset of a comma b. All right, and similarly for y1 belongs to cd, that implies y1 is an interior point. All right, y1 has a neighborhood with epsilon 2, y1 plus epsilon 2. This neighborhood contain subset of c comma d. from these two we are getting any epsilon, which is the minimum of epsilon 1 and epsilon 2. By this epsilon we're having a neighborhood n epsilon of x is a subset of x1 and y1. That is, we have selected this x1 and y1 over here, x. So we are having a neighborhood of x over here, neighborhood of this x with minimum of the radiuses of x1 and y1. So this we can say that since this is a subset of since this is a subset of CD, all right, and since this is a subset of CD AB, all right, x1 is a subset of AB, y1 is a subset of AB, we get that this n epsilon x is a subset of x1 and y1. From that we get that this x is an interior point of this Cartesian product. That is very easy. All right, next thing, next concept that we have here is, hopefully I'm explaining hopefully I'm explaining correctly, and my explanation is clear. And if you think that if you have any doubts, or if I did any mistakes in explaining, you can comment me down below so that I could rectify the mistake. And thank you for watching my video. And in the next video I'm going to explain the concept of E closure, closure of a set, closure of a subset E, and what is the limit points, and how that I've already explained what is the limit points. I'm going to explain the closure of E and some of the related theorems as well.